Dear students, welcome to this third session of our chapter 10, the S block elements. Today we will discuss some of the important compounds of sodium, which include sodium carbonate, sodium hydroxide, sodium chloride, and sodium hydrogen carbonate or sodium bicarbonate. Let's see the first one, sodium carbonate, which is otherwise said to be washing soda. And we know the formula for that one is Na2CO3 10H2O. This we have learned in grade 10. So sodium carbonate is Na2CO3 10H2O and it is prepared by Solvay process. Sodium carbonate is prepared by Solvay process. How it is prepared? It is prepared by passing carbon dioxide through ammonia. When you pass the carbon dioxide through ammonia, it gives you ammonium carbonate. So the equation can be NH3 plus H2O plus CO2 gives NH4 twice CO3. This is not complete. So ammonium carbonate is then converted to ammonium hydrogen carbonate. That reacts with sodium chloride to precipitate out sodium hydrogen carbonate. So the second step is carbonate is converted to ammonium hydrogen carbonate. So we can see here NH4 to high CO3 plus H2 plus CO2 gives NH4HCO3. This ammonium hydrogen carbonate is treated with sodium chloride and we are getting sodium hydrogen carbonate plus NH4Cl. The sodium hydrogen carbonate is heated to form sodium carbonate. Thus, we are getting our sodium carbonate in a large scale plus CO2 plus H2O is there. Now let's see the properties of sodium carbonate. It is a white crystalline and odorless powder which exists as a decahydrate, that is Na2CO3 10H2O. Because of this 10 molecules of water, it is said to be decahydrate and it is named as washing soda. It is hygroscopic. Hygroscopic means it absorbs moisture from the air and it is readily soluble in water. That's why when we use for washing purpose, it dissolves completely in the water. On heating, the decahydrate loses its water of crystallization to form monohydrate first. Again, if you heat it above 373 Kelvin, the monohydrate becomes completely anhydrous. That means no water content will be there and it changes to a white powder which we are naming it as soda ash. So anhydrous form is said to be soda ash. See this formula Na2CO3 10H2 is decahydrate. When you heat it, it becomes monohydrate. Na2CO3H2, only one molecule of water is there. Again, if you heat above 373 Kelvin, what happens? The monohydrate becomes anhydrous. No water content is there. Na2CO3 plus H2O it becomes. And this Na2CO3, where the water content is not there, is named as soda ash. Now let's see some of the uses of sodium carbonate. It is used in water softening, laundering, and cleaning purpose, as well as in the manufacture of glass, soap, borax, caustic soda, and also in the paper, paint, and textile industries. It is also used as a important laboratory reagent both in qualitative as well as quantitative analysis. Now let's see the next compound, that is sodium chloride, which is NaCl. How we can prepare this one is the crude sodium chloride is obtained by crystallization of brine solution, that is NaCl solution. But it contains some impurities, that is sodium sulfate, calcium sulfate, magnesium chloride, calcium chloride, etc. And to obtain this one, to obtain the pure sodium chloride, what we have to do is the crude salt is dissolved in minimum amount of water and then we have to filter it to remove the insoluble impurities. The solution is then saturated with hydrogen chloride gas and the crystals of pure sodium chloride separates out. This way we can separate or we can prepare the sodium chloride in a large scale. The calcium and the magnesium chloride, which is more soluble in water, then the sodium chloride remains in the solution itself, and then we can just skip it off or filter it off. So like this we are getting the pure sodium chloride. Now what are the properties of this sodium chloride? It is easily soluble in water and partially soluble, or we can say insoluble in some of the liquids. They are white crystals which do not have odor, but they possess what? A taste, and that is salty taste they possess. In its aqueous state, that is in molten state, NaCl acts as a good conductor of electricity, and it is due to the free movement of the ions. And we know that NaCl is having one cation, one anion, which is in the ratio 1:1. And the electrons or the free movement of ions are possible in the aqueous medium, so it becomes a good conductor of electricity. Now, what are the uses of sodium chloride? We know that it is used as a common salt or the table salt for our domestic purpose. It is also used for the preparation of sodium peroxide, sodium hydroxide, sodium carbonate, etc. Now let's see the third compound of sodium, that is sodium hydroxide, or the other name of that one is caustic soda. The formula of sodium hydroxide is NaOH, sodium hydroxide. Now how it is prepared? It is prepared commercially by the electrolysis of sodium chloride. Sodium chloride is brine solution we are taking here also. In Kastner-Kellner cell. This is a apparatus where the process is done. A brine solution is electrolyzed using a mercury cathode and a carbon anode. We know the cathode is negatively charged and anode is positively charged. So these two electrodes we are using in a solution or in a brine solution. When you pass the electricity, what happens? The sodium metal gets discharged at the cathode because sodium is positive charge and this cathode is negative charge. Opposite charge they will go. Combines with the mercury to form sodium amalgam. It combines with mercury. When a metal reacts with or combines with mercury, it gives you amalgam. So the sodium when reacts with mercury, it forms sodium amalgam. And the chlorine gas is evolved at the anode. Chlorine is negatively charged and here the anode is positively charged. So like this, the electrolysis process is done in the brine solution where we have taken this process Kastner-Kellner cell. And the reaction you can represent like this. At the cathode, what happens? Na plus electron giving in presence of mercury we are using. So it forms sodium amalgam. We are writing in this way, sodium amalgam. And at the anode, chloride ion gets what or converts into chlorine gas with the evolution or with the release of one electron. This is what cathodic and anodic reaction. The amalgam after this is treated with water to give sodium hydroxide and the hydrogen gas. That is sodium amalgam when you treat with water. Na amalgam plus H2O gives you what? 2NaOH plus amalgam is what? Hg. 2Hg is here. That's why here it is written 2Hg. Plus what? You will get the hydrogen gas. So what we need? We need the caustic soda. Here we are obtaining the caustic soda by the method electrolysis of brine solution. Now, what are the properties of sodium hydroxide? It is a white, translucent solid. It melts at 591 Kelvin. It is readily soluble in water to give a strong alkaline solution. It's very alkaline in nature, or the strongest one we can say. Crystals of sodium hydroxide are deliquescent. Why? Because it absorbs the moisture from the air. The sodium hydroxide solution at the surface reacts with the carbon dioxide in the atmosphere to form sodium carbonate. So when you have the sodium hydroxide solution in a reagent bottle in the lab, if the cap of the bottle you are not closing, what happens when it comes in contact with carbon dioxide on the top of the or on the neck of the bottle, it forms the white substance which is said to be sodium carbonate. Now let's see some of the uses of sodium hydroxide. It is used in the manufacture of soap, paper, artificial silk, and a number of chemicals. It is used in petroleum refining, in the purification of bauxite. Bauxite is an ore of aluminium. In the textile industries, and for the preparation of pure fats, oils, and also as a laboratory reagent. So these are some of the uses of sodium hydroxide. Now let's see the last compound of sodium, that is sodium hydrogen carbonate or sodium bicarbonate. And the other name of that one is sodium hydrogen carbonate is baking soda or NaHCO3, sodium hydrogen carbonate. The sodium hydrogen carbonate is also known as baking soda because it decomposes on heating to generate the bubbles of carbon dioxide. As we know that when you make the cakes, it is fluffy, that is leaving holes in between, and it becomes very light also. So because of that one, it is said to be baking soda. And how it is made? It is made by saturating a solution of sodium carbonate with carbon dioxide. Na2CO3 plus H2O plus CO2 gives you 2NaHCO3. That is, we can say the reverse process is for the preparation of sodium carbonate. So like this, you can remember also how it is formed. The hydrogen or sodium hydrogen carbonate is made by saturating a solution of sodium carbonate with carbon dioxide, we said. Okay. Then what are the properties of this sodium hydrogen carbonate? It is a white crystalline solid having a density of about 2.2 gram per milliliter. It has alkaline taste and is sparingly soluble in water. Sparingly means partially soluble in water. The solubility of sodium increases, sodium hydrogen carbonate, it increases with the rise of temperature. When the temperature is increased, its solubility also increases. Now let's see the uses of sodium hydrogen carbonate. It is used as a mild antiseptic for skin infections. It is used in fire extinguishers and also as a reagent in laboratory. So these are some of the uses of sodium hydrogen carbonate or sodium bicarbonate. Thank you. We will continue in the next session.